you by thesis123.com. I learn and teach online.
Here's the next question, number 43. A balanced positive sequence 3-phase AC voltage source is connected to a balanced star-connected load through a star-delta transformer as shown in the figure. The line-to-line voltage rating is 230 volts on the star side and 115 volts on the delta side. If the magnetizing current is neglected and IS equals 100 angle 0 amps, then what is the value of IP in ampere? Alright, so a whole lot of information. The figure seems a little daunting, but it shouldn't. Once you go through the question very carefully, you will be able to segregate which side is what. Now the question says that the 3-phase AC voltage source is connected to a balanced star-connected load through a star-delta transformer shown in the figure. The line-to-line voltage rating is 230 volts on the star side and 115 on the delta side. Okay, so let's begin by writing down the per phase current on the secondary side. Before we go into all of that, you should know they have asked what the value of IP is. Now IP is I phase of the primary side. This is what they have asked. So we'll do this step by step. We start with, let me note this down here. Okay. We start with the per phase current on the secondary side. I phase secondary. I phase secondary. Okay, so the current given to us is 100 angle 0. Do you see that? IS equals 100 angle 0. But since we are calculating the phase current, that would be 100 divided by root 3. Angle, it's not 0 anymore, it is 30 degrees. Now this is because of the line current being connected in star connection. Okay. Next, let's calculate the turns ratio of the primary to secondary side. That will help us further in calculating what is the I phase for the primary side. Turns ratio of primary to secondary. So the turns ratio can be represented as V phase of primary divided by V phase of secondary, which is, now take a look at the values of voltages given here. The line to line voltage rating is 230 volts on the star side. Now when we are writing it in terms of phase, that star side 230 becomes 230 by root 3. Okay, star side becomes 230 by root 3 for phase, okay, divided by V phase secondary and 115 volts on the delta side. Now delta side is anyway given in terms of phase, so we write that down as it is 115. I hope that makes sense so far. Now if we solve this, we get 2 divided by root 3. Now this is our turns ratio of primary to secondary, 2 by root 3. Now utilizing this, we should be able to find out what the value of I phase for the primary side is. Now since we know that in terms of the primary and secondary, V phase primary by V phase secondary equals to I phase secondary divided by I phase primary. Using this ratio, we can find out what is the value of I phase primary. So I phase primary equals I phase secondary into V phase secondary divided by V phase primary. Okay, so this is what we have now. Let's substitute the values and see what we get. I'll note it down on the side here. Okay, so I phase primary equals root 3 by 2 into 100 divided by root 3 angle 30. So solving this, we get a value of 50 angle 30. 50 angle 30 is the value for I phase primary. And that matches with option A. So this is the entire solution, and I hope it has helped.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.